Hello everyone. So I will wait for 5 minutes or so, then I will start. I will just wait for others to join. Okay. So can someone confirm whether my screen is visible and I'm audible or not?
Good evening, sir. Audible, sir.
Yeah. So my screen is also visible, right?
Yes, sir.
Okay. Okay. So today we'll be talking about fourth week lectures. Okay. So let's begin. So in the last week, you would have watched lectures which talks about different operations which you can operate. I mean, perform on different matrices and vectors and logical operators. So we'll be looking into all those things, and from next week, it will be a bit more interesting where we'll be dealing with logics and all, like if else and so on. Today we'll be talking about matrices and some logical operators. So you all know, in past 2 3 weeks, we already discussed that how you can create matrices, right? So we'll start with that. So I will also demonstrate in our subsequently. So as you can see in this command, how we were making matrices till now is that we were putting the function matrix and our data, which is, for example, here I am mentioning 1 to 12, and how I want to arrange these 12 numbers is in 3 rows and 4 columns. Okay, so all these things you already know. Now we'll be checking how we can change different rows, columns, how we can subset these matrices in case we are not interested in whole matrix at once. We are just interested in some, a specific set of rows and columns. For example, when you go into neuroimaging data, there are multiple channels and so on. Okay, so your data is organized into 3D matrices or 2D matrices where you have different rows called which have different, I mean, data from different channels and different columns which depict, let's say, different time points. But you are only interested in few of the channels, okay, not all. So in that case, that's where subsetting is involved, and we rename rows and columns for more meaningful information, because every time it is very difficult to say that okay, always select fourth column or fifth column. Instead, it is more meaningful to say that let's fetch names column or education column. So that is more meaningful. That's why it's good to know that how you can rename column once you have matrix, and how you can subset and do different operations on those matrices. Okay, so we'll also open R and I will show you how these things actually work. So as I mentioned earlier, I'll be operating everything in R Studio so that I can also share you the script in case you guys are interested. So okay. So first of all, we'll be making one matrix, and we'll try to change rows, row names, column names, and different subsetting we'll look into. Okay. So for example, let's say, so I am saving my data in a matrix named X, sorry, a variable named X. And uh, so till now we only talked about how you can generate numbers in a sequence like 1 is to 12 using a column, right? But there are other ways also how you can generate different sequences. For example, there is a command called seq, where you can mention a starting point and end point, for example 2 to 12, and at what step you want, I mean, what is the difference you want between two variables, for example 2, 4, 6, 8. So all those things are possible. We are, as of now, we are just dealing with very simple things. So there are many things which we may not be able to cover, but there are many things that exist in our. Okay, so as of now, for simplicity, we are using these things. Okay, so, and in 3 rows and 4 columns we want to arrange. Okay. So now, as you can see, we have our X matrix. So if I simply try to print, you can see that these numbers are arranged as per columns. So by default, it does not save these values as per, I mean, in rows in increasing order. For example, if you want our matrix to be saved in, I mean, our values to be saved as per rows, in that case, we need to provide rows as true. So we will not go into that because those things you already know. We are here mainly focusing on how to change different names and subsetting. Okay. So, for example, if you want to change the names of the matrix, okay, so whenever, so in R, there is this one good thing that when you will start typing any function name, most probably you will already see different functions which are starting with that name. For example, as you can see here, as I started with call names, so you can see what all functions are available. Okay, so here you can see call names is already there, so you don't sometimes it is easy to know that what are exact function, whether particular letter is uppercase and lowercase, because if let's say I put n capital here, it will not work. So that is one good thing, that as soon as you start typing any function, you will get all the functions and you can see it. Okay, so now in this case, you see that we have 3 rows and 4 columns. Okay, so we can specify any names we will with and those needs to be string characters. And since I have to put I have 3 rows, so I need to put 3 row names as well. And I need to combine all those 3 names with C. So what are and as you I mentioned earlier, you can name anything your columns or rows. So for example, here I have 4 columns. So as of now, let's put C1, C2, C3, C4, and but you can give any meaningful name which you want. Okay. Uh, I know all these. Sorry. Yeah. Sorry. So now if I check my variable, I can see. So earlier it was showing index because there were no column names specified. Okay. So so earlier it was simply showing that this is first column, second column, third column, fourth column. There was no column names or no row names. So that's why it was depicting indexes. Now since we changed or we gave specific column names, that's why it is specifying the exact names that we provided. Okay, and similarly, I can change row names also. And again, I need to provide my matrix and what are my row names. For example, here R1, R2, R3, and R4. I mean, we have 3 rows, so we can provide 3 row names. Now again, if I try to print my X, now you can see we already gave some names. So depending on how what is your actual data, accordingly you can give meaningful names to it in both rows and columns. For example, when you do chi-square and so on, okay, in those tables you have rows and columns. So there, these things makes more sense. Okay. Now coming to subsetting, let me check. Okay, first of all, how you can get different, I mean, row sum, or I mean, sum of all the rows, sum of all the columns, means, and so on. So those things also we can see. So if you want to get the sum of entire row, for example, 1, 4, 7, and 10, in that case, you can simply say row sum, and so here S is capital. So that's what I was telling, that sometimes when you're starting, you don't know that what is the exact function, right? And what letter is uppercase or lowercase. So as soon as you start typing, so even if I type sum, you can see that correct names will start appearing. So for example, row sums. Okay. So even if I type the small s, it is giving me correct option that okay, this is the exact function which you might be interested in. Okay, so you can put that, and if I return enter, so you can see that so for first row, this is my sum 22. For second row, so since I specified, I already provided the names to these rows, R1, R2, R3. Accordingly, it is showing me that what is the sum of entire row. If you are not providing any of these, so it will simply provide one vector that what are the three values of for three rows. So for example, the sum of these values is 22, second row sum 26, and third row sum is 30. Okay. Similarly, uh, for columns, again your function is call sums, and again you can provide your entire matrix, and it will give you the values. Okay. Similarly, if you want to calculate mean instead of sum, then sorry, row means, and again you can put x, and similarly call means. Okay, so this is pretty straightforward. And now, if you're not, let's say if you're only interested in sum of one column or two column, how you can do that? Okay, sometimes you don't want to perform calculations in entire matrix, because here we are only dealing with three rows, four columns. Sometimes my data may have, let's say, 5,000 rows and 2,000 columns. Okay, and so it will be huge data, and you might not be always interested in all the rows and columns. Okay. So let's say you are only interested in first row or second row, but all columns, and or vice versa. Okay. So that's where subsetting helps. Okay, or not just mean, you want to do any calculation, anything. Okay, linear regression, anything. So in that case, you are not, it is not convenient to do any analysis on all such variables at a time. Okay, so in that case, you want to subset. Now, how you can subset from any large matrix? So let's make another matrix which is quite big. Okay, let's say x1. Uh, So let's say I'm just providing any number of. So it will just give me some warning that I think it may give some warning because okay. So now I have, let's say, this data. Okay, I have 100 entries, that is 100 rows and 20 columns. Okay, or let's increase. So now we have 1,000 rows and 20 variables. Okay, now let's say my data is organized as per column, and I'm interested in different columns, not all columns. Okay, so let's say my second variable is, let's say, age. Okay, I want to calculate what is the mean age. Okay, in that case, I don't need to do mean for all the variables. Okay, or all the columns in this case. So now in that case, how we can proceed? Okay, so in that case, this function will remain the same, but we need to subset a particular column, okay, in this entire matrix. And same logic applies to tables as well. We'll come to it, we'll talk about it whenever we'll deal with data, I mean tables and so on, but this logic remains the same. Okay, now how you can subset it? So one way is that you can subset that one particular variable in different variable. Okay, for example, let's say I can say age. Okay, and here I can say subset a particular column from my matrix. Okay, for example, from x1, let's say from second column I want to subset. Okay, which is, so I can simply put comma, nothing before comma, because all rows and second column. Okay, and I can subset. Uh, sorry, this is supposed to be square bracket. Okay, since we are using indexing, right? And if we subset now, we you see we have call only one variable named age, where I have different set of values. Now I can get a mean of it. So now we can simply put mean and age, right? So it will give me appropriate this thing, appropriate value. If we want to do and or if you are interested in more than two columns, okay. For example, two to let's say fifth column. Okay. Now if we do this, it will give the mean of all the values, okay, whichever are there under age. I mean, now it will simply average all the values which are there in this age. Okay, although uh, it has different rows and columns, but we don't want that. Okay, what we actually want, let's say in now, okay, let's put it back for simplicity. Okay, let's say, okay, let's say we want to perform operation on a set of rows and columns. Oh, then mean is not appropriate. Mean or ST or SE, all those things work well when you have one vector. Vector means a sequence of, no, I mean not sequence, but a list of or different elements in a single row or column. Okay, that's where these means or ST, these basic functions work very well. But if you have different rows and different columns, that's where you need to go into row means and row columns. Okay, if there is a 2D matrix or any 2D structure on which you want to perform any operation, that's where you need to use that. Okay, if you are simply interested in one column, this will work very well. Okay, now if you want to do operation on only these number of values, so in that case you can, this is how you can subset, let's say 2 to 5th column. Okay, or let's say another set of columns you can say. So as I mentioned, if you want to put more than uh, one value which is not in sequence, for example I want uh, columns from 2 to 5, and let's say 15th column and 18th column also. So in that case, you can, this is how we can combine. So this says that select the columns 2 to 5. So it will make us, so as you can see the input, it will put 2, 3, 4, 5, and 15 and 18. So it will subset these many columns. Okay. Now if I run this, you can see now this is my data. So now finally it has 6 columns. Okay, so this v it uses for variables by default if you are not providing any row name or sorry, column name. So now if you want to perform this row means or column means, so you can say column means and this new variable. Okay, and it will print you the mean of all these columns. Okay, since we had 6 columns, so you will see here there are 6 values, okay, for each column. Or instead of providing like this, you can directly input your, you don't need to save it in a different variable, you can directly give that as an input. Okay, and your answer will be same. So this is how you can subset. Similarly, if you are interested in different rows, so let's say 1 200, let's say I'm interested in 1 200 and 200 to 500 rows. Okay, and let's say same columns. Okay, So this entire part is telling, so which is before comma, it is telling that subset these rows, and whatever is after comma shows that subset these columns, and the square bracket is for indexing that. Whatever, wherever these columns or rows are there, simply subset those things in a new variable called row set one. Okay. Now if I run and you see my variable, now there are 401 entries. I mean that is 401 rows and 6 columns. Okay. So this is how you can subset, and accordingly again, if you want to, let's say, calculate row means for this set, then you can again say row means and a row set one, or you can provide that data set. Okay. So now you see for each row you are seeing one entry. Okay. And for last row, that's 400 first row, this is your mean. For 377th row, this is the mean, and so on. Okay. And these are showing indexes. Okay. So this is how you subset different rows or columns of interest, and accordingly you can proceed with mean and any other statistics. Okay. So let's check what else. Yeah. So one more thing is that sometimes you want to start with nothing, but nothing means you have a structure that I want to save some data in a matrix of 3 by 4, right? But you want all values to be zero, in which you can keep writing different rows and columns. Okay. For example, let's say I have to save uh, okay, let's say I have age of three individuals. Okay. Or age, okay, see, let's say 21, 22, and 23. Okay. Or 25. Okay, let's say there are three individuals whose age is this. Okay. But and you want to put it in a matrix. Similarly, you have two three more variables which uh, sorry, yeah, you have, let's say, three more variables which you want to later put in any sum matrix. So in that case you might be interested in starting in making one empty matrix. Okay. Empty matrix, or matrix starting with zeros. Okay. In which you can keep filling things. So in that case, how you can proceed is that you can simply say matrix, and you can put 0 and how many rows and columns you want. Let's say 3 rows and 3 columns I want. Now here, if you are just providing one input, it will simply put that value in all rows and columns. Okay. And similarly, if I put here 1, you can see all will be 1, and so on. Okay. So let's say I want to save this data inside this. Okay. Empty mat. Okay. Now on this matrix, I want to add this data in, let's say, third or second column, let's say. Okay. Then as you know how you can index something. So if you want to put data in second column, what you need to do, you need to first provide the index of rows and columns where you want to put those specific values. Okay, since I want to put these three values, okay, let's make it zeros. Okay. So now this is my empty matrix. Okay, I want to put my values in, let's say, second column. That is, I want my 21 here, 22 here, and 25 here. Okay. In first and third column, I am planning to put some other values later on. Okay. Now, how we can proceed with that? So in that case, I can start one, I mean, make one empty matrix, or matrix with zeros, and then I need to provide index. Okay. That what, in which column I need to provide values. Since I want to provide in second column, so all rows, sorry, so all rows, so everything will be empty before comma. So so since it is a 2D matrix where there are rows and columns, so first I want all rows, so comma, and second column. Okay. After that, what values actually I want to put? I want to put these three values. Okay. So I can simply put these values here and hit enter. Okay. Now if I again try to print my matrix, you can see that these values are now inserted in the second column. Okay. Now, so this is one thing. Okay. Now let's say you have these same three. You have age of three people, but your matrix has, let's say, 10 columns, 10 rows. Okay, but you have data of only three individuals. Okay, now, but you know that where exactly you need to put that data. Okay, let's say this 21st age is of second person, and 22nd age is of third person, and 25th age age of 25 is this 10th person. Okay, so in that case, how you can write? So logic remains the same, whatever we are discussing till now. That now we want to put in specific rows, not all rows. Okay, so this column remains the same, that we are interested in putting this data in second column. Okay, so that remains the same, but which rows, that changed. Okay, so how we can now specify, since these are non-continuous rows, so I can put C, and I can put which columns, sorry, rows. So I have, let's say, data for second person, third person, and 10th person. Okay, now I can run this, and now if I print, you see that's exactly whatever, however we wanted. Now my data is saved at an appropriate place. Okay, so that's why you need to understand these in indexing, subsetting, and putting data. Understanding your data, that uh, let's say if I make this 25, I add one more thing. Okay, one more variable, and I try to run this command. You see, it will give an error. Why? Because we only provided three places where these values can be put, but these values are more than three. Okay, so that's why it is giving error. So these things you need to be careful about, that whatever values you are specifying, these should match the entities where you want to put those values. Okay, that count should match. Okay, otherwise it will give error, sometimes warning, and uh, it may not behave the way you want. So it's your job to cross check beforehand that your inputs are correct. Okay, so this is how you can make any matrix with zeros or ones. You can simply provide zero and your rows and columns. Okay, next, how you can make diagonal matrix. So in diagonal matrix means that only diagonal elements are whatever values you want, rest everything is zero. Okay, so for that, function is DAIG, which stands for diagonal in R. And let's say I want uh, all my, I mean, three rows and three columns, and I can put diagonal, and you will see that it will make one. I mean, all the diagonal values as one. Similarly, I can change it to anything, and it will do the same. Everything else will remain zero, and the diagonal values will change to that particular number. Okay, so these are the basic things about matrices. Okay. Now another thing is that when you want to transpose your matrices. Okay. So let's say, okay, let's take that longer data set. Okay, which was this? Where was that? Yeah, X1. Okay. So now here you have 1,000 rows and 20 columns. Okay. Sometimes you will, when you will be dealing with different data sets, sometimes you may need to transpose your data, that is changing rows into columns and columns into rows, because I need sometimes I don't. Okay, so it's better to know how to do that. And in other programming languages, I mean, in most programming languages, this transposing works simply if you put this sign. Sorry, one second. So simply if you put this, it will transpose. For example, I want to, what was that, x1. So in MATLAB and all, this will transpose your entire matrix, that it will change rows into columns, columns into rows. But in R, this doesn't work. Okay. So here, what you want to do instead, you need to put uh, T, right? And if you put enter, okay, let me save it in some variable. Let's say x2. Okay, so I want to save my transposed x1 matrix into x2. Okay, so now if you now see my x1 data and x2 data, so x1 has 1000 rows, okay, 1000 entries, that is 1000 rows and 20 columns. Now my those 20 columns became 20 rows, and we had 1000 rows, so those rows became 1000 columns. So it is simply shift in rows and columns. Okay, data is not changed here. Okay, so sometimes you will need that. So that's what we wanted to clarify here, that in R it is T. Okay, to whenever you want to transpose any matrix. Okay. And okay, this subsetting we already talked about how you can subset the data. So all these things I already mentioned, how you can transpose sorry, subset if you have continuous rows or columns. If you have non-continuous, if you want to subset a particular specific column or rows, you can use C and is separate the different column index using comma and run. And you can put that new matrix in a new variable name up to your, it's up to your convenience. Okay, how you want to operate, because if you're not putting these new let's say if you are again and again typing the same thing, it's not very convenient. So it's better to put this entire resulting matrix in a new variable, and now and after that keep using that. Okay, so and if you're interested in particular value, for example, let's say, so here we were taking the example. Okay, so in empty mat, so here we put a different column and age of different individuals. Now let's say if I want to fetch the age of 10th individual after all this, so how I can fetch, I can simply say whatever my variable, I mean table was or matrix was, and I can simply say that fetch data of 10th person, which is located in ninth or second sorry second column. So age of 10th person, which is located in second column. Okay, so simply 10 comma 2, and if I run, I will get 22. So that's how you fetch different data set, I mean different values from your matrix. And these you will be using very frequently when, I mean later on. Okay, next how to do some calculation between matrices. So let's look at that. So first okay, let me put some comments here for your, so that you remember later. Okay, everything else is well known, so I don't need to put comments. Okay, so let's take this example again. Okay, so now we'll see how you can perform different operations. Okay, So let's make it a square matrix here as of now. Okay. So why? So currently you can see that currently I'm getting a warning. Okay. Why I'm getting a warning? Because as an input, I told it to put the values from 1 to 12. Okay, which are actually total 12 values. But I gave an input that put this data into 3 rows and 3 columns. Okay, which is not possible because total, as per my later information, I need 9 values, but as an input, I provided 12 values. So that's where there is a mismatch. Number of values are not equal. So that's what you are actually seeing here as a warning that 12 is not equals to 3 by 3. Okay. So that's how you can read the warnings. But if we check the data, so it will by anyway it will put the data. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So it put 9 data points into 3 by 3 columns. So these things you need to worry. Need to be careful. Okay. So I am ignoring that as of now. So let's see how we do calculations, or let's say directly, let's print it directly. Let's make it 9 to avoid warning as of now. So now this will be your matrix, initial matrix, in which you want to add any scalar values, or you want to do calculation between matrices. Okay, how you can do that? So here, if you want to add any scalar value, you can simply say plus and you can enter any value. Okay. And if you run, it will simply add that particular value to all the values, irrespective of which row or column. Okay. So 1 became 3, 3 became 5, and so on. Okay. So every value in every value, 2 has been added. Now, how it will work if we have two matrices? Okay. So again, let's copy the same and let's say 21 to 29. Okay. So now if I do this, what it will do, it will simply okay. So this is one matrix. So this is one matrix and this is second matrix, and we want to add these two matrices. Now how it will work? So whenever we are trying to do any operation in between two matrices, it will do element wise calculation. Okay, we'll so in your 10th or 12th class, you might have seen that when you multiply matrices, it works slightly differently, right? So where it takes values of each row and each columns, and it sums different okay, we'll come to it in a bit. So as of now, let's see how these different simple calculations work, that is plus minus and so on between matrices. So all these works element wise, that is first element of first matrix and first element of the second matrix will be added if we have provided plus sign, and similarly minus and so on will work. So here if you see, my first value of first matrix is 1, first value second matrix is 21. Now if we simply add these two matrices, our resulting matrix is this. So first value now you see is 22, which is sum of 21 and 1. And if we check this value 38, so it is simply sum of 29 and 9. Okay. So all these calculations work element wise. Okay, plus minus and multiplication and division. So even if I put multiplication sign instead of plus, that will do element wise calculation only. Okay. So now you can see this 20 so 21 into 1, 21, and 44, sorry, 22 into 2, 44. So that's how these calculations are working. So whenever, but in your as I mentioned earlier, in your 10th and 12th classes, you would have saw that this is now things. This is not how multiplication actually works between matrices. How it works actually is that you multiply each element of first row with each element of sorry, from first matrix you take each element of first row and multiply it with uh, the first column of the second matrix, that is 1 into 21 plus 4 into 22 plus 7 into 23, and whatever that resulting value will be, that should come in the first row first column. Okay, that's what you know how matrix multiplication works, right? So how you can achieve that in R? Okay, so for that instead, for that simply multiplication sign will not work in R. For that there is a specific command which is one second. So here you need to put percentage sign, multiplication and percentage sign. In that case, it will operate that way. Okay, whatever you have been taught in your earlier schools. Okay, so this is how actual multiplication between matrices works. Okay, so that is one thing which is specific to multiplication on with the matrices. Okay, and similarly, if you want a combination of different rows and I mean more than two elements, that is if you want to, let's say, do this calculation and you want to add some, or let's say minus 29 or anything. So what will happen is that these two things will work element wise. Okay, that is first element of first matrix will be added with the first element of second matrix, and after that this minus 29 will be added to all the elements of the resulting matrix. Okay, so if we check this, this will be the resulting values. Okay, similarly if you provide so similarly you can provide more than two matrices and these things will operate the same way. Okay, but if you want to, so let's say if you want to include this again. Okay, instead of any scalar value, so now in this case what will happen? Okay, so okay, so in this case what will happen? So again, as soon as more than two operations are coming into picture, it will work as per BODMAS. Okay, first this part will be solved, after that this part will be solved. Okay, the resulting matrix will be, I mean this will be then adding to the resulting matrix. And if I run this is the output. So if we simply see the output of this part, which is 270, okay, and here this part is getting added, so 370 plus 1, which is 871. Similarly 1086 plus 4, 1090. Okay, so that's, so even in matrices everything work as per Baldwin's. So wherever you are having more than one calculations, it will follow the same rules. Okay, now all these things we already talked. Yeah, one thing which you might already know, that whenever you are trying to perform this multiplication, particularly this multiplication which does not perform element wise, so here number of rows in one matrix will be equals to number of columns in the other. So till now we were dealing with the square matrices, that's why we did not observe any error. Okay, so now let me change few things. Okay, so let's make it 3 by 4 matrix. Okay, and let's say I have both 3 by 4 matrices. Okay, now So I can show you the matrix. Let's clear the console. So now this is my one matrix where I have three rows and four columns, and I have another matrix where again I have three rows and four columns. Now, will that work? It will not. Okay. If I simply put this multiplication, if I simply say this will work. Okay, because it needs same number of rows and columns. Okay, because it is doing element wise calculations. Okay, so that's why it will work. But this will not work. Okay, why? Because you have already know that when you are multiplying, for example, as I mentioned, how you do actual calculation between matrices, I mean multiplication. So you multiply 1 with 21 plus 4 into 22 plus 7 into 23. Now 10 is extra. Okay, that's why it will not work. So for to make this work, what you need that there should be four values which can be multiplied with these four values, which means that four rows, I mean, if this one matrix has four rows, another matrix should have must have four columns. Okay, now if I simply try to run this, you will see there is an error. Okay, so now if I change this matrix to 4 by 3, okay, second matrix 4 by 3. Now if I print this and print on this part, now you can see now this calculation is possible. That is, 1 can be multiplied with 21 plus 4 into 22 plus 7 into 23 plus 10 into 24. So now this calculation is compatible. Okay, now if I run, you can see now there are 3 by 3 matrix, resulting matrix is 3 by 3. Why? Because this is arranged as per, I mean, there will be whatever number of rows are there in the first matrix, accordingly you will see the square matrix. Why square matrix? That you can figure out by multiplying. You will understand how these things are working. Okay. Uh, and similarly, if I change the order of these things, so here first matrix has three value, I mean three rows, so that's why you are finding this matrix to be three, resulting matrix to be 3 by 3. If I if we do the reverse, sorry, that is my first matrix is, let's say, 4 by 3, and second is 3 by 4. Now it will result in 4 by 4 matrix. Okay, so that's how these matrices work. Okay, and if you multiply any matrix with its transpose matrix, uh, I mean, there is also a function which can do that, and that is cross product. So for example, so one way is that you can simply transpose your matrix and multiply with it. That is one way of doing the same thing. Otherwise, you can use this function called cross product. Sorry, and you can simply say that matrix, and it will do the job for you. Okay, so in case you need it. Now, another thing is that how you can merge different matrices. Okay, and again, this is also very useful. Many times you will need that part. Okay, how to, I mean, where there will be many instances where you need to merge different rows and columns, and not rows and columns, but different matrices or different data sets. So for that, there is a function called rbind or cbind. Rbind means bind the rows, so r means rows, cbind means columns. Okay, bind by columns. So Let me show you another example. So let's uh, let's make another matrix which is mat2, and okay, so let's say we have these two matrices, mat1 and mat2. Again, let's clear it out. Okay, so now we have these two matrices. Sometimes we may need to merge these two matrices. Okay, that is, we want to just append one matrix at the end of the second matrix, either by row wise or by column wise. So in that case, how we can, so if we want to merge row wise, okay, so what we can do, I can simply say r bind, and I can put two matrices, and this order matters here, that is, which will be at the end. Okay, so now under first matrix, so for it took for first row of first matrix, that is 1 2 3 4, and second row, I mean first row of the second matrix, and it just put that those values at the end of the second, I mean first row, first matrix rows. Okay, so it is simply putting pasting second matrix below the first matrix. Okay, and similarly, if I want to do this calculation column wise, and this R we can change to C, that is C bind, and you can see that my first matrix is as it is, that is from 1 5 9 2 6 10 and so on till 12, and after that the second matrix has been added afterward. Okay, now here again it will work or it will not work if they are not same number of rows and columns. For example, if I change my mat to 3 by 3, okay, so now my second matrix is this part. Okay, so in that case our bind will work because it is not taking into account how many columns you have. Okay, one second. But in C bind it will create problem. One second. So okay, so in R bind your number of columns should match. There should not be any extra, because what R bind will do, it will simply put the new values or values from the second matrix under the first matrix. So number of columns should match in that case. Okay. In column bind, what it will try to put this entire matrix right after this first matrix. But it will not be able to perform that operation because this part can be put in front of this part. Okay, till here it will work, but it will not be able to find any values which can be appended at the end of this fourth row. Okay, so that's why this C bind will not work, because for R bind you need number of columns to be same, and for C bind you need number of rows to be same. So that's how R bind and C bind works, or row bind and column bind. So both matrices should be of same shape. Okay, so that's one thing. Now let's take a look into another property. I mean, another thing, that is how you can get inverse of a matrix. Okay, so here there is one thing that you must know. So here if I try to do, so I have this mat one. Okay, and if I simply try to, so you might already watch the lectures and you know how to get the inverse of a matrix. Okay, that is, you can use solve function and it will give you the inverse. So let's try that. Solve. mat 1, it should have worked, but it did not work. Why? Because for it to work, your matrix should not be singular matrix. What I mean by singular matrix is that your your any row or column should not be, I mean, there should not be linear dependence between rows or columns. Okay. What I mean by linear dependence, for example, this is my row. I mean, this is my matrix. Okay, on which I am trying to perform this inverse part. Okay, inverse matrix I want to calculate. Now, what I mean by linear dependence is that if this fourth row, okay, this is exactly same as 2 into second row. Okay, so if I simply do this part, okay, for example, mat 2 comma into 2. Okay, so you see my fourth row is exactly same as second row multiplied by 2. So that is, there is a linear dependence between different rows. If that is the case, there is no possible solution or inverse solution for this matrix. Okay, and instead of manually checking that, there is a function which I listed here, that is d. So it is determinant function. If your determinant of this matrix comes out to be 0, you will not be able to get an inverse solution for that matrix. For example, mat 1, sorry, det, so det for determinant, and mat 1. And if I check, one second, okay, so again these things work on a square matrix. So let's make it a square matrix first. And again there will be a linear dependence as I mentioned earlier, so it will again not be able to solve. Now if I want to check whether there is any solution or not, if its answer is 0, there is no inverse solution for this matrix. Okay, so that's how you can check whether inverse matrix is possible for your matrix or not. Okay, now let's say I can manually specify 9 values. Okay, let's say, okay, now if I check this part, if it is not 0, I must be able to get the inverse solution. So this is the answer. Okay, so that's one thing that you should know, that if you're not getting uh, a solution for any matrix, I mean inverse solution for any matrix, the problem is that it is a singularity matrix. How you can check that? Using this determinant function. Okay, what is singularity matrix, what is inverse, those theoretical part you can check. Okay, or you can google it and understand. Okay, here we are just talking about how to implement those things in R. Now, if you multiply your original matrix with the inverse matrix, you must get the identity matrix. What is identity matrix? That where all the diagonal values are 1. Okay, so let's check. So since we were able to get the solution of this part, now we can verify whether this solution is correct using on this part. Now, currently, you might be seeing that there are values, that is, my diagonal values are just not one, and there are other values also below and above diagonals, but these values are very tiny. Very tiny means these are almost near zero. So these are scientific notations. I hope you guys know, and in case some of you don't know what these scientific notations mean, so it means that if any value is ending with e, so this e is not exponential. Okay, if any value is ending with e, and after that you may see plus or minus sign. Okay, minus sign means that whatever value is there, you need to add, I mean, shift this decimal before this. Okay, that is, so currently this value is suggesting that you need to put shift this decimal on the left hand side and keep adding zeros. Okay, and how many values back you need to shift it? 16 times you need to shift that zero. For example, let's say any value is something like, let's say, e minus 3. Okay, 1 point, let's say this is the value that you might be getting. Then what it actually means is that I need to shift this dot uh, or decimal towards left. Okay, that is, so what it actually means is that 0.0012. Okay, that's what it means, that this decimal is supposed to shift from here to three points. Okay, that is 1, 2, and 3. So that's what this e means. And if this is a plus value instead of minus, it means that this decimal is supposed to go the other way. Okay, that is 1, 2, so then 0, 0. So, and you need to add zeros after or before that. So that's how you read these scientific notations. Okay, now just to verify for you people what I can see, so I can simply round or truncate this matrix. Okay, so let's save this matrix into mat3. Okay, so this is my mat3. So just to for better visualization whether this is identity matrix or not, I can simply round it, or I can simply remove the values before and after decimals. So again, this created a problem because this truncate works slightly differently. So that's why we can't use that. So I think here for visualization, round is more appropriate. So here we can see that your diagonal values are 1. So that's what we say when we say identity matrix, that your diagonal values are 1. Everything else is 0. So that means that our inverse solution is correct here for this particular mat1 matrix. Okay. Okay. Next, there is something called eigenvalues, which you can get using a function eigen. So that is eigen, and again you can put your matrix, and it will give you eigenvalues and eigenvectors. Again, I will not get into what all these things are. These things become meaningful when you do different statistics. For example, in factor analysis, you need eigenvalues and so on. Okay, those things we'll talk about if required later on. Okay. Okay. Now we are shifting from matrices to logical operators. Does anyone have any questions till here? Feel free to unmute and ask or type anything. So this eigen, I mean, I don't want to go into the theory of it. So mainly it is giving the three eigenvalues, which are the important part. I mean, I hardly use these parts. I never used it, so I also don't know much about it. But uh, for example, when we do scale constructions and all, for example, for assessing someone's anxiety and so on, where we have, let's say, 50 items or 50 statement, uh, by which we ask individuals that, uh, in different ways, that how anxious you are. And there we check that what statements were really helpful in assessing someone's anxiety. So there we calculate eigenvalues and so on, and there we have cutoffs. In eigenvalues also you have cutoff. For example, if that value is one per, I am from psychology, so in psychology, whenever you do use eigenvalues in factor analysis, any value above one is acceptable, below one we remove those items and so on. So there are different uses of these eigen. How you can use it in I mean, how you use it in your domain will varies slightly. And if you get want to see the documentation of eigen, you can simply say question mark and check. You will get some information about it, but I did not use it much, so I also can't give you very comprehensive information about this function. But we'll see if we need it later on.
Thanks, sir.
Yeah, any other question, anyone? Because now we'll be talking about logical operators. Any problem in matrices that you might be facing in your assignment, or understanding any part, or when you're trying it is not working out. Okay, if there is no question, let's move to the logical operators. Now, all these things I already introduced you guys earlier, but let's now look at its applications. Okay, how you to actually use it in R. Okay, so we'll look into all these things one by one. Okay. So one thing you should know that whenever we say logical operators, the resulting values are true or false. Okay, so here you are comparing or equating two or more values. Okay, and if you are compare two values, like is one greater than the other, you will get answer in terms of true and false. Okay, so that's what logical operators do. It will not give you any specific value. Instead, it will give you true or false, okay, logical answers. So let's see how to use them. Okay, so let's start with less than equals to and so on. So now, so here I am showing very basic calculation. For example, is 4 less than 3, and you can see answer is false. I mean, these are very basic things. And is 4 greater than 3, you will get an answer of true. Is and these things also work when you check uh, with vectors. For example, see, let's say you have different values. Okay, and you want to check whether what all values are greater than 4, let's say. Okay, and if we run this statement, it will check each entity. That is 2 greater than 4, false. Is 3 greater than 4, false. Is 4 greater than 4, it is equals to, but it is not greater than false. Sorry, 4, so again it is false. Is 5 greater than 4, true, true, and so on. Okay, now here it is only giving you the values, not values, it is just telling the index. Okay, which value satisfy the condition of true. Okay, if you want to actually fetch the value, okay, which are greater than 4, so in that case what you are supposed to do, so this is giving you index, one sort of index, that is there are six values which are true or false. Now if you want to fetch these values whichever are true, so in that case, so let's, instead of directly giving that, let's save this vector in a variable called var1, okay, or v1. Okay, now instead of putting this, I can put v1 and the answer will remain the same. Okay, now how I can fetch actually the values which are greater than 4 instead of just getting true or false, because for me I'm not interested in true or false. So how I can fetch, I can simply use these true and false values as indexes. How we can do that? We can put uh, same v1, and as you know that for indexing we use square brackets, and since this is just one vector, there are no rows and columns, so we don't need to provide any comma or anything before or after. So now if I run this, you can see it will fetch the values wherever my logical output was true. Okay, and what are those values? 5, 5 and 6. Okay, so that's one use of these logical operators and how it can be used to fetch values. These logical operators will directly not give you values whichever are greater than 4 or less than 4. Okay, you can use the resulting data, that is true or false output, as an index to fetch the actual values. Okay, so that's one use. Similarly, I can use other functions. Let's ignore the indexing part as of now, and let's just directly check different operators. Now less than or greater than or equals to. So now if I'm checking my whether my these values are greater than or equals to 4. 2 is not greater than or equals to 4. 3 is also not greater than. 4 is not greater than, but it is equals to 4, so that's why this part is true. Then 5, 5, 6, they are already greater than 3. I'm sorry, 4. So again, all these things are true. Again, if I want to fetch these values, I can simply use the resulting data as an uh, index using square brackets, and I can fetch those values from my same variable, that is v1. So that's how you can use less than, greater than, or less than equals to, and or greater than equals to. So simply you can put these values and so on. So accordingly you will get the output. Now other function is that, so like you are using these functions less than or equals to, you can't really use equals to like that. Why? Because equals to you use for assigning values. Okay, for example, if you say v2 equals to 2, it will not equate, it will assign the value 2 to v2. Okay, so for equating you need to use equals to. Okay, so is any value equals to 2 in v1? So that's what we can check using v1. I mean double equals to, that is, this is true, that is first value is equals to 2, so it is true. Rest are not equals to true, not equals to 2, so they all are false. Okay, now you can check which all values are not equals to 2 using this negation function, that is this part. So it will tell all the values which are not equals to 2. So is 2 not equals to true? And 2, answer is false. Is 3 not equals to 2? True. 4 not equals to 2? True, and so on. So that's how these logical operators work. Other than that, there is this negation sign. So it cannot be used directly between when you're comparing two variables. That function, that negation function, you use against a logical output. For example, here we are using on this part, okay, whether particular set of values are equals to 4, I mean greater than 4. So you see false, 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 true, true, true. Okay. Now we need to use this negation function with the output of this thing. That is, which of these conditions are not true. Okay. For example, now, so it will in short will simply reverse the output. That is, false will become true, false will become true, and true will become false. So what actually it is doing? So so when you run this part, okay. So first print this, then this part, and then this part. So now what, how you can actually understand that what actually it is doing. So here what we are comparing is 2 greater than 4, right? Which we got as false. 2 is not greater than false. What this part is comparing is that is this particular operation, which whatever we performed, is its value false. Okay. So since this is a negation, we check that is the resulting value false. That's what this part does. Is so from this operation, you can see that first value was false. So that's what it is checking. Is my this value false? True. Is my second value false? True. Is my third value false? True. Is my fourth value false? No. So instead of putting true, it gave output as false. So most of the times you will never need that function, but that's what it does. Okay. Now coming to these and or. Okay. Now these you use when you are comparing, you already have logical operators. For example, this you want to compare against some other function, for example, and okay. So my v1 is this. Now what it is doing, it is simply comparing whether both are true. So from this part, this is the output. From this part, this is the output. And what it is comparing is that it is doing element wise comparisons. Okay. What it is saying that is both these values in the first index are true, and the answer is false because both are not true. Okay, so that's why you can see here false. Are these two values true? No. So answer is false. Are these two values true? False. Are these two values true? One is true but one is not. So again false. Again, are these two values true? False, and so on. Okay. So that's what it is checking. So and checks for whether all conditions satisfy the all conditions are true or not. Okay, and it does element wise calculations or element wise comparisons. Similarly, if you instead of using and, I can use or. Okay, either one of them is true or not. Okay. Now if I check, one second, this. So now here you can see is either of these two. Sorry. So now here it compares whether either of these two are true or not. Okay. So for example, in first case, is either of them true? No, so false. In second element of both are again false, so resulting answer is false. Third also false, but in third case, one of them is true. So either this or this. Is any of them true? Yes, so resulting answer is true, and so on. Okay, so this is stand for and, where all conditions should satisfy the answer of true. Okay, that is all conditions should give you logical output as true. Here it checks for is there any output as true or not. Okay, so that's the difference between these two. Now another thing that you have, if you would have watched all the lectures properly, you would have seen that professor to using these functions and or double and double or what actually it does. Now, can someone unmute and tell whether you tried or whoever has tried those things as per lectures? Did you got appropriate output or not? Can someone unmute and tell? Okay, so this is
So,
my,
sir,
yeah.
here double and or double or means it will just check the first value as a in the logic. It won't go for the next values and then give the output.
Did you tried that in your R
Yes, sir.
and it worked?
Yeah.
So currently my V1 is these set of values 2, 3, 4, 5, 5, 6. Okay. And if I want to, if I use double and instead, so this already run. If I do this, what will be the answer? Can you tell? Can you? I mean, what is expected answer before running? I am asking.
So false answer will come.
Okay, let's run. It gave me error. Why? Did you try that in your R? Just try it in your R. Uh, do you have your laptop open?
Yeah.
Okay, just try this. Everyone, you guys can try in your laptops and tell for whom this thing is working and for whom it is not. So save your this, or you can save any values in V1. Okay,
Uh,
not just these
Sir,
values.
in this case, we have to put C.
Where I already have C here, right?
It is.
So just try to do put any set of values into any variable and then try to perform logical comparison using double and tell me the output. All of you can try. That's how you learn. Just watching will not work. Did you perform?
Performance.
Okay. Others also you can try. Okay. One person is getting error. One person is getting false. Or Bindu, are you getting false answer or you are getting an error? So I'm asking you to perform on a set of values, that is on a vector. These comparisons.
Yeah, I got that error.
You got error? Okay.
Yes.
Anyone else? I want you guys to try it right now. Neerath, did you try? You were doing right. Okay. So why exactly it is happening? Let me tell you. Those lectures which you are seeing right now were recorded long back. Okay, 3 4 years back, and there are many updates after that in R. Okay, in those lectures, if you would have watched, whatever he run, exactly same thing. That is not, maybe not exactly the same numbers and not variable names, but the similar way he used, and it worked. Okay, why? Because that time, I mean, this R keeps evolving. People keep correcting different mistakes. Okay, even that time it was not intended to compare a set of values. Okay, that this double and or double R function is not, was not intended to compare all the values. Okay, that's why that time also it was comparing the first value and so on. So these people are development team. In the recent versions they corrected that part. Okay, if you are providing a set of values, it will simply give you error. Okay, after, I mean, whatever version that professor was using, after that there were few more revisions where initially it was giving warning, and after that in recent versions it is starting giving error. Okay, there is nothing wrong with R. It's just that this double and is not how it is supposed to, I mean, it was not supposed to work that way it was working earlier. Okay, this is the actual use which they updated now. Okay, that is, it compares scalar values. Scalar means only one it compares only one values. Okay, not a set of values. Okay, since this will result in four values and this will also result in four values, so that's why it is throwing an error. Okay, instead, if I simply say 3 and 3 here, okay, now you will get an output. Okay, proper output, because now there is only one value here and one value here which it needs to compare. Okay, so that's where it works. So that is one correction. I mean, this is something that you should know, uh, and I'm clarifying that those lectures were old and that's why it was working that time and now it is not. Okay, so these things you should know. And same thing is with or also. Now, whatever that professor was telling is not wrong. Okay, he was telling as per the version he was using. Okay, I am telling as per the version I am using. Again, in new updates they may again change some things. Again, this function will start behaving differently. Okay, for currently this is how these functions work. Okay.
So, sir, this or sign, how to input? Because I was trying, I am not able to get how the or sign from the keyboard we have to give an input.
So you are using Windows or uh,
Windows.
Windows? Okay, I don't have Windows. Let me open some Google image or something.
Neerath, you can try the
So this,
using shift slash. You can see.
yeah. So this button you
Okay.
are seeing right above enter. So you can use shift and this part. So
Okay.
this will simply change that icon to that one. So
Okay. Yeah. Thanks.
yeah.
Got it now.
Okay. So that's the actual use of double and double OR. So if there are, if you're comparing more than one value, it will throw error in recent versions of R. Okay. and if you check your current version, it will be more than 4. Sorry, this part, it is more than 4th version. What he was using, I think, was less than 4. So these updates came in the 4th version of our 4.2 or something. So that's the reason you are not able to use this. If someone has our version of older version of R, for example, let's say 3.2 or so on, this function may work as it was working in those recorded lectures. Okay.
I had one question, whether
Yeah.
this lecture is being recorded for any future reference.
Yeah, I'm recording that, and I hope you are already getting all the links of all previous lectures also. So all these links have been posted on your classroom. Not,
Okay.
yeah. Now there are few more operators which are like XOR is true is false. So we'll look into that also, how what they actually means. So here you compare again true or false. For example, XOR. Okay, in bracket you can provide two set of values. Okay, that is if 3 is greater than 4, or let's do this. So for first, answer is false. For second, answer is true. And if we run that, we get true. And if we put both as true, it will give us answer as false. I will tell in a moment what it actually means. So here, what it actually compares is that whatever conditions you have, is any of them true, but not all are true. Okay, that's what it says. Here only this condition was true, that is 3 is greater than 2, but this was false. So we get an output as true. In second case, we are checking that is 3 less than 4, true. Is 3 greater than 2, again true. Is is one condition or the second is true? No. Why? Because both are true. Okay. So that's how you read XOR. Okay. Is one or the other is true, not all are true. Okay. So if both are true, you will get false. If both are false, you will get false. If any of the conditions are true, then it will give you true. Okay. That's how you read this XOR function. Okay. And one second. And this is true, and
Uh,
yes,
One question here, does XOR work on only two arguments or maybe more?
I think it should work on more also. Maybe it works on two only. I mean, I never used it, so I was not aware. I don't think it works on more than two. You can Google it if there are other ways. Or one second. I think it works on only two elements because we never use it because it is not required in most of the cases. So I think it can only operate on two inputs. Okay, now is true. So this simply does the same thing that if so it is asking if the output of this particular condition is true or not. If it is true, it will give true. If it is false, if it is not true, it will give false. For example, is 3 greater than 4? No, so false. And similarly, so again, is 3 greater than false? So the answer is false. So is it false? So this is asking that is the resulting value of this input is false. Yes, it is false. So that's why it is giving answer true. Okay. So this thing you should understand that what exactly your input is asking. Okay, it is asking whether your resulting value is false or not. Yes, it is false. So that's why it is saying that okay, yes, the resulting in value is false. So whatever you are trying to say is true. Okay. And this true and false is just the output that you always give when you use any logical operators. Okay. Now this is the table to see how things work. So if two, so let's say when you're comparing these two inputs, okay, for example, if I just talk about two inputs, so if one logical statement is giving you true and other is giving you false, or both are giving you true, so in that case what will be the answer in case of different question, I mean operators. So if both are false and you are checking whether either of them are false, so is either of them are true? No, so answer is false. Is either of them is true? Yes, one of them is true, so again here true. Here is either of them is true? Yes, it is true. And in fourth condition, both are true. Is either of them is true? Yes, it is true. So you are getting true answer. Now, if we talk about second and condition, so now here it is asking is both of them. So when we are using this, we are checking that is both of them, sorry, either of them are true. Here we check are both of them are true or not. Okay. So in first condition, are both true? No, so false. In second condition, are both true? No, so it is false. In third condition, are both true? No, it is false. In fourth condition, are both true? Yes, so that's why it will give you answer of true. So this is a truth table. And again, if we talk about negation, so it is simply opposite of the output that you are getting. For example, uh, is false false? I mean that's how you read. Is this value false or true? Is this value false? No, it is not. So and output will be false. Is this value false? Yes. So answer is true. Is this value false? No. So the answer is false. Okay. And this XOR, how it works. So that's what I mentioned. Is any of them are true? Not any. Is any one of them are true? No, both are true. So that's why it is false. The second condition, is any of them is true? Yes, one is true. So answer is true. In third, is any of them is true? Yes. So answer is true. Is any of them is true? No. So answer is false. So that's how these things work. Now these are few more things. We already talked about all those things. Yeah. So another thing is that so earlier we, if you remember in the very beginning in first or second lecture, I think, or first or second live session, we talked about how to check whether particular entity is a number or character, right? Similarly, you can check if any particular output is logical or not. Okay. So for number or collect or strings, we were using is number is character. For logical, we use is logical, and again output will be false. False. And negation, I already told you how it works. works. So I can show you how is logical works. So for example, I can save this value in another variable. Okay, so my now v5 value is true and it is logical, as you know. So but how we can check that is logical v5. Okay, now why you need to check? Because okay, let's see. Sometimes when you are working with tables and all, sometimes when you will see your table, you may see that a particular column has true and false. Okay, but that might not be a logical vector. Okay, you might be thinking it is logical, but when you import that data in R, it may not be logical for R. Okay, you will see exact thing that it is written as true or false, but R will not read that as R. In that case, you need to check whether your particular column is uh, uh, that thing or not. I mean, logical or not. So, for example, now if I check is dot logical and v6. See here, even when v6 value is true, it is showing that my v6 value is not a logical output. I mean, it doesn't have a logical uh, entity. Okay, because we use inverted comma, so now it is saving this true as a string, not as a logical input. Okay, and if you want to convert that as a logical, you can use that as I think now. So now if I say v7, now it will convert this true into a logical operator. Now if I see my v7, it is showing true. Now again we can check whether v7 is logical. Now we can say yes. Now after conversion, it is a logical operator. Logical. It has logical entities. Okay. So that's where you need to check whether. So just like some numbers can be strings, similarly, whatever you are seeing true or false may not be actually true or false. Okay. You need to convert it into logicals if it is not. Okay. So that's one thing. Is true, is false, all those things we already checked. Okay, let's do you guys have any questions till now before we start questions? Any questions, anyone?
No, sir.
Okay. Okay, let's look into some of these questions. So first is if this is a matrix, so that's what I think I mentioned in the very beginning, that that is not, I mean, 1:12 I was using, that is not the only way to make a sequence of numbers. You can also make a sequence like you can use a function called seq, and in bracket you can put from which to which number, for example from 2 to 20 at a step of 2, that is 2, 4, 6 and so on. So it will put those values in 3 rows 3 columns, and by row true. And so let me so so what will be the resulting matrix here is like this. So we have 3 rows 3 columns, so 2. So since we are doing row equals to true, by row equals to true, so 2, 4, 6, 8, 10, 12, 15, 16, 18. So this will be the resulting matrix. Now it is asking what will be the output of row sums. So
So B will be the answer.
yes. Okay, now in the second question, now it will have 2 rows, 3 columns, and again by row. So what will be the column means? So your matrix will be, sorry, 4, 8. So here it is asking for column sum. No, call means.
So call means it
So
will come only 2, but here 3 are given.
no, so call means, so this part you sum and divide by 3. So 10,
No.
20, 26. 1 second.
No, here answers are given 3. 3 options.
Where you are saying, oh,
A, B, C, D option, if we see there are 3 numbers total, but
yes,
only 2 numbers will come.
yes,
No, no, it is 3 column. Here we have mentioned 2 column.
yeah.
So 4,
Some,
8, 12.
no, no, no. So something went wrong. I made the wrong matrix actually. So
And
4, 8,
C
12.
answer will come.
Yes, 6. Yeah. So this is the correct matrix. So 2 rows, 3 columns.
C answer will come.
Yes. Yeah. Next, this is the matrix here to fetch these values. So again,
11, 12, 13, 14, 22.
so now it is asking for second to third row and first to second column. So in this row and first and second column. So this part. 1 second. Is it correct?
Here option itself is not there.
Yes. Maybe I think options might be wrong. Okay, ignore that. So that's how I can subset any rows and columns. So first those rows and then those columns. Okay, again I write it the wrong way, sorry. It is saying 4 rows and 3 columns. So 11, 12. So second and third row.
B. B is
Yes.
answer is coming.
Okay, next. So 3 rows. So what will be the diagonal values? So it will be a square matrix. So and values needs to be input by rows. So 3, 5, 7, 9, 11, 13. 3, 11, 19. Yeah. Next.
2, 3, column 2, 4, 6, 8, 10, 12.
Should I solve or?
A. A.
So it's inverse of the matrix.
Transpose
Sorry, yeah,
here.
transpose. Yeah. Okay. Next, there are two matrices. What is the correct operation to perform the multiplication?
B.
Yeah, because this will only do element wise.
Element wise.
Yeah. Next, which command will produce this output? There's not much to think here. So first matrix has two rows, second matrix also has two rows.
R bind B.
Yes, so the second will be appended at the bottom. So it is
Yeah.
R bind. Next, X is this. What are the results of these?
X is greater than 20,
So yes,
true,
it will be
and
true.
X is less than 30, true. True, false. That is
This is also false, right? So what will be the answer? Are both of these true here? True. Is any of these true here? No. So false.
no.
So B will be the correct answer here. Okay. So which command fetches values greater than 15 or less than 30 here? Any guess?
E.
Yes. So since we are saying and both conditions should be satisfied, and since I'm mentioning fetching the values, so it means you are again fetching from the same variable. So that's why
Same
we
value.
use that as an indexing. Okay, resulting true false as index we used, and we can fetch using this. Next, in this matrix, what will be 3 comma third comma second value?
Third row, second column. So 21, 22,
What?
30. D.
Okay, this I will not do. This, which command extract the second row? This is very simple.
A.
Yes, here you don't even need to worry about this entire part. Second, which command produces this? Or let's ignore this question. Okay, what are the dimensions of this transpose of X? This answer you should give immediately.
B.
Yes.
B.
So here you can simply say it has 3 rows, 4 columns. So transpose will be 4a by 3.
4 by 3.
This part. So what will be X plus Y?
A.
Yes. So which statement is correct?
C.
Yes.
Sol. B.
Yeah. So what is the result of this?
X greater than 20 and X less than 25. First is true, second is false. B.
Okay. Okay, now this is the last question. Can you tell what will be the answer of this? So these are values of P, these are values of Q and R.
And true, and true,
And
and
also
R.
carefully see where are brackets. So here in first case it is asking whether P and Q both are true. Okay, P and Q. So here answer will be true. In second case R and P are both true. R and P. Yes, it
Both,
is true.
both are true.
And here R and Q. Yes, both are true. So is anyone so see brackets are here. Okay, first bracket.
So first,
So the resulting value for this is true. Is any of
true,
them true? Yes, it is true. And are both of these true?
true.
Yes, true. So answer will be true. Next in second condition, what will be the answer?
P and Q are true. R or Q. Or means anyone is true. True. R and P false. So true or false. True. True. So here also true will come.
Okay. Next.
P and Q are true. False. R and P true. R and R or Q true.
Answer is true.
False or true. Third one is also true.
Okay. Next.
P and Q false. R and P false. R and P false. R or Q false. So here false.
Okay.
P and Q false. R and P false. R or Q true. False and
See, if any of these two conditions are false, answer will be false ultimately because it is saying asking both of them should be true.
both of them.
So if any of the condition is false, you don't need to proceed. Okay, if any of these
Okay.
conditions is false, answer is automatically false. Sorry, not any of these because it is or, but If this overall answer is false, complete answer will be false. So what's the answer here?
Here it will be true.
It is false. So it's P and Q. P and Q. They are false. R and P. R and P. These also both are not true. So again false, since two are false, ultimately it will become anti-statement will
False.
become false. Okay, next.
P and Q false. R and P false. Next also false.
Next.
P and Q false. R and P false. This also false.
The last one will anyway be false only. Okay, that's it. Any other questions you may have?
No, sir.
Okay, so should we end the session?
Yeah.
Okay, we'll meet next week.
Yeah. Okay.
Yeah, thank
Thank you,
you.
sir.
Okay.
Bye.